Namaste. Myself Kumbhararyan from Dr.Rajaram Mahavidyalaya, Srigonda. Today we see Einstein's postulate of quantization of energy and photoelectric equation. Max Planck's hypothesis about light, that is, light emitted from the source in the form of small packets called as photon or quanta, and each photon having energy h nu, that is, E is equal to h nu. Here h is Planck's constant and the value of that h is 6.623 into 10 raised to minus 34 joules second, and nu is the frequency of radiation. Nu is the frequency of radiation. This assumption is used by scientist Einstein to explain photoelectric effect. This assumption is used by scientist Einstein to explain photoelectric effect. Then, for the explanation of photoelectric effect, in last lecture we see what is a photoelectric work function. What is a photoelectric work function? The energy required to remove the electron from metal surface, that energy, that minimum energy is called as a photoelectric work function. Here, radiation which are emitted from source and travel in the form of photon, and that photon, when collides on the metal surface, there is a collision between photon and electron, and the total energy of that photon is gained by electron, and that gained energy is used by the electron in two ways. That is, part of energy is used to escape from the metal surface, and remaining part is used for the movement of electron. Here, energy of the photon, it is the E is equal to h nu. E is equal to h nu, that is the energy of photon. And phi naught, it is the photoelectric work function, that is the energy required to remove that electron from metal surface. And this photoelectric work function is equal to h nu naught, where nu naught is the threshold frequency. Nu naught is the threshold frequency. What is the threshold frequency? Threshold frequency means the certain minimum frequency at which electrons are emitted from the emitter plate. That frequency is called as a threshold frequency. Then, electrons are emitted only when frequency of incident radiation is greater than or equal to threshold frequency. Greater than or equal to threshold frequency. Then, from this relation, we write this threshold frequency is equal to photoelectric work function divided by this h, where h is a Planck's constant. In this explanation, Einstein used to explain photoelectric effect. For this purpose, Einstein used Max Planck's hypothesis, that is, light is propagated in the form of small packets called as a photon or quanta, and each photon or quanta having energy h nu, where h is the Planck's constant, nu is the frequency of incident radiation. Then that energy of the photon is used in two ways. When photon collides with the electron, part of energy used to escape electron and remaining energy is used for the movement of electron. Then what is the photoelectric work function? Photoelectric work function is energy required to escape the electron from metal surface, and that energy is equal to h nu naught, where nu naught is the threshold frequency, and threshold frequency means the minimum amount of frequency at which electrons are emitted from the metal surface, that is the threshold frequency. Then here this relation is that frequency of incident radiation is greater than or equal to threshold frequency, then and then electrons are emitted, otherwise electrons are not emitted. And from these two relations, this relation we can determine another relation, that is threshold frequency is equal to photoelectric work function divided by h. This is the explanation about, means from this we conclude that whatever may be the intensity of incident radiation, electrons are emitted only when frequency of incident radiation is greater than or equal to threshold frequency. Greater than threshold frequency. Okay. Then second explanation is that photoelectric effect is the instantaneous process. Instantaneous process means what? When photons are incident on that metal surface, there is a collision in between photon and electron. At that time, there is no time lag between incidence and emissions. Means this process is an instantaneous process. That is, this process occur in a nanosecond, that is a 10 raised to minus 9 second. Means there is no time lag between incidence and emission. This is the explanation about time. Then third of the explanation is that about this photoelectric equation. More intense beam contains more number of photons, and there is a more number of collisions in between photon and electrons. That's why the number of electrons emitted from emitter plate increases, and therefore rate of flow of electrons increases, and we get more number of photoelectric current. From this we conclude that more intense beam is responsible for more electric current. Means intensity and photoelectric current are proportional to each other. यामध्ये या ठिकाणी ज्या रेडिएशन मध्ये इंटेन्सिटी जास्त आहे त्यामध्ये जास्तीच्या प्रमाणामध्ये फोटॉन्स असतील आणि त्याच तेवढ्या प्रमाणात इथं कोलिजन होईल आणि ज्यादा प्रमाणात इलेक्ट्रॉन्स बाहेर पडतील आणि करंट आपल्याला ज्यादा मिळेल. दिस इज द एक्सप्लेनेशन अबाउट इंटेन्सिटी. Means intensity and photoelectric current are proportional to each other. Then in last lecture we see experimental setup. We consider experimental setup. That is, potential is applied in between two electrodes, that is emitter plate E and collector plate C. Then photoelectric current depends upon potential also. That is, potential applied to the collector. Positive potential applied to the collector is responsible for more current, and which is measured by emitter. Then here we can explain this by graph. On x-axis there is a potential, and on y-axis there is a current. From this zero potential, we increase the potential, then it is also that current also increases. And if potential also increases, then current becomes constant. means it remains constant, current does not increases, that value of current is called as a saturation current. Saturation current. And this saturation current is different for different intensity of radiations also. Different radiations also. Then the electrons emitted from emitter plate goes to the collector. Then here in last lecture we see this is the emitter and electrons are emitted from emitter plate and goes to the collector. Here is the transparent window, and from this transparent window radiations are incident on this emitter plate. Here energy of the photon, that is E is equal to hν, and this energy of photon is used in two ways. That is, part of energy is used to escape the electron, and that is called as a photoelectric work function, and remaining part is used for its movement. That means it is used for its motion, and from this we obtain the relation like this, that is a 1/2 mv square max. This is the kinetic energy and this is the work function. Means part of energy, that is the energy of photon hν, is used in two ways, that is for motion, and remaining part, that is for its photoelectric work function. यावरून आपण या ठिकाणी हे रिलेशन या पद्धतीने सुद्धा सांगू शकतो की 1/2 mv square max is equal to hν minus photoelectric work function. This is the kinetic energy. Kinetic energy means what? Energy of the photon is used in two ways, that is some part is used to escape and remaining part is used for its movement, that is a motion, that is for its kinetic energy. That kinetic energy is equal to hν minus phi naught. This is the kinetic energy. Then this kinetic energy depends upon potential also. Here potential in between this emitter plate E and collector plate C can be changed by potential divider arrangement, and from this we write 1/2 mv square max is equal to this relation charge into potential, where V naught is the potential applied between collector and emitter. From this we conclude that the potential relation between potential and kinetic energy, this potential is equal to 1/2 mv square max divided by E also. Means kinetic energy depends upon potential. Kinetic energy depends upon potential. Then next, when photon incident on the metal surface, then electrons in that metal are randomly in motion, and these electrons in atom moves in different orbits. The electrons in outermost orbits are loosely bound to the nucleus, but innermost orbit, that electrons are tightly bound. Means more number of energy is required for the escape of that electron, and little amount of energy is used for its motion. Means what? When electrons are well inside the atom, then small amount of energy is used for its kinetic energy. Means what? The situation of electron is also responsible for the current also. Here, when potential is given, positive potential is given to the collector, and that is responsible for the kinetic energy also. Then next, explanation about this, that when kinetic energy of this emitted electron is equal to this relation charge into potential, then electrons are just emitted and these electrons are not reaches to collector and we do not get the photoelectric current. We do not get the photoelectric current means kinetic energy is more than this. Kinetic energy is more than this means charge into potential. Then and then electrons reaches towards the collector and we get photoelectric current. And from this we write also relation, that is 1 upon 2 m v square max is equal to h nu minus phi naught. And when this relation, kinetic energy is nothing but charge into potential, which is equal to h nu minus phi naught, and potential, that is stopping potential, is equal to h nu upon e minus phi naught upon e also. This is the relation between potential and frequency. Means stopping potential also depends upon the frequency of incident radiation. And this is the different for different. In last lecture we see about this. या ठिकाणी पहा, जर आपण हे ग्राफिकली दाखवलं तर या ठिकाणी हे जे आहे इथं हे वेगवेगळ्या पद्धतीने या ठिकाणी आपण दाखवू शकतो की हे जे काही पोटेन्शियल आहे हे पोटेन्शियल या ठिकाणी negative potential or stopping potential is different for different frequency of incident radiation, and from this we conclude that stopping potential depends upon frequency of incident radiation. आता या ठिकाणी Einstein's postulate of quantization of energy and photoelectric equation यामध्ये आपल्याला जो काही याचा समरी आहे तो असा या ठिकाणी in 1905 साली आइन्स्टाईनने जे मॅक्स प्लँकने जे काही थेरी मांडलेली होती की photons in the nature of light वरती, that is light propagates in the form of photon, याचा वापर करून photoelectric effect एक्सप्लेन केला. And for this purpose Einstein got Nobel Prize in 1921. याचे एक्सप्लेनेशन साठी satisfactory explanation about the photoelectric effect was awarded. याच्या एक्सप्लेनेशन साठी आइन्स्टाईनला या ठिकाणी नोबेल प्राइज दिले गेले 1921 साली. आणि यातलं महत्त्वाचं इक्वेशन असं की एनर्जी ऑफ फोटॉन इज युज्ड in two ways. That is, part of energy is used for the escape or liberate, and remaining part is used for its motion. That is, h nu is equal to 1 upon 2 m v square max plus phi naught. This is the very important relation of photoelectric equation. Okay. Then dual nature. Next lecture of this topic, that is dual nature of electromagnetic radiation. Wave particle duality. Wave particle duality of electromagnetic radiation. In last lecture we see different scientists suggest different nature of light. According to Max Planck, light is propagated in the form of photon, and this photon that is a momentum is also associated with the photon. But according to scientist Quantum, he explained the nature of light, and the nature of light is a particle according to scientist Quantum. But when we explain different different optical phenomena like interference, diffraction, reflection, then these optical phenomena can be explained on the basis of wave nature of light. Wave nature of light means optical phenomena just like interference, diffraction, reflection, refraction are explained on the basis of wave, and wave nature was suggested by scientist Einstein. For this purpose, we consider diffraction. When the slit width is very small as compared to the wavelength of light, then diffraction pattern is observed. And when slit width is more than the wavelength of light, then that time slit width, that is the fringe width, is observed. And from this, the nature of light is wave. Means optical phenomena cannot be explained on the basis of particle nature, and that can be explained on the basis of wave. On the contrary, photoelectric effect is explained on the basis of nature of light, that is the nature of light is a photon. Means these two phenomena, photoelectric effect and optical phenomena, both are explained on the two assumptions which are opposite or vice versa. That is, optical phenomena are explained on the basis of wave nature of light, and photoelectric effect, Compton effect are explained on the basis of particle nature. For this purpose, we can consider the nature of light is a dual, that is a wave as well as particle. This is the wave particle duality of electromagnetic radiation. Okay, thank you.